Good morning, student. Today I am here to make the concept clear on the term refractive index, and also I will make you clear some of the conceptual question, especially the numericals. Student, what is refraction? The basic definition already you know it, but before that I will proceed with an example. You must have studied in lower class there are two kinds of substances. One is known as transparent and the other is opaque. Transparent means light can pass through it. This you already know it. Opaque means through which light cannot pass. Transparent objects are like glass, water, and opaque objects are like wood, your books. These things are opaque, through which light cannot pass. Now let's talk about speed of light, student. Speed of light is maximum in vacuum, and that value is here I have written 3 into 10 raised to 8 meter per second. In air also the speed is near about same. The speed of light in glass is this much. This value, student, you don't have to learn it by heart. You can apply the formula to find out, okay? Speed of light in water is 2.25 10 raised to 8 meter per second. So speed of light is maximum in vacuum. Now student, if I want to find out refractive index of water, first let me explain the meaning of the term refractive index. Actually what happens is, student, whenever light changes the path, and it will change the path only when the medium is changing. Remember, student, what I am saying. Suppose light is traveling, say, from air to water. So at the interface where the light is getting water, it is entering the water, the medium is changing, so that light will bend. How it will bend, we'll see it in the later on. But light will bend, means it will change the path. When it will bend? When the medium is changed. This bending is, student, known as refraction of light. Now suppose the light is passing from air to water. Next time it is passing from air to glass. In both the case, path of the light will change. But student, this bending will not be same for both. For water, this bending of light will be different. For glass, this bending of light will be different. So in order to measure this bending, how much is the bending taking place, the term refractive index is used in physics. Now I am coming to the basic mathematics of it, student. For example, I want to find out refractive index of water. Student, this is the formula. If I want to find out refractive index of water, the formula is speed of light in vacuum upon speed of light in water. And this refractive index comes out to be 4 by 3. It is an experimental value, student, 1.33. This value you have to remember, student, 1.33. So what I have said, refractive index of water is 1.33. What this means? When the light enters water from air, its velocity will reduce. How much its velocity will reduce? It will reduce to 1 upon 1.33 times its velocity in vacuum. So this basic formula you have to remember. If I want to find out refractive index of any medium, student, and first medium I am supposing it to be air or vacuum, then the formula will be speed of light in vacuum upon speed of light in medium. Now since the speed of light in vacuum is maximum, so refractive index of a medium will be always be greater than 1. It will be always be greater than 1 because speed of light in vacuum is maximum, student. So this is the one way of finding refractive index, student. Now student, you see there is another term. When suppose the first medium is not air, the medium is other than air. Say light is entering from water to glass. Means the first medium or the second medium is not air. In that case we define another term known as relative refractive index. So here I have given a formula for it. Refractive index of water with respect to glass is equal to ratio of refractive index of water upon refractive index of glass. This value can be less than 1 or can be greater than 1 also. Now students, see the basic thing which is hidden here. I have written refractive index of water. Remember student, of water means the water is the medium in which refraction is taking place. And just now I told you the meaning of refraction is bending. So it is water is the second medium student. Water is the second medium. Then I have written with respect to glass means glass is the first medium. This means light is entering from glass to water. So where the refraction is taking place? It is taking place in the glass. Sorry, in this case it is taking place in the water because I have written refractive index of water. So the formula is, in the numerator I have written refractive index of water and the denominator I have written refractive index of glass. This means on the numerator the refractive index of second medium comes. See the student, the hidden facts. Whenever you calculate relative refractive index, remember the numerator refractive index of second medium will come. And remember what I am saying, which I am saying refractive index of second medium. This I am talking about absolute refractive index. And what is absolute refractive index? When one of the medium is air. With respect to what, when the refractive index is calculated, that we call it absolute. In the previous page, as I have shown you, refractive index of water is 1.33. That is absolute refractive index. This word is extra, it is added. The absolute means light is entering from air to that medium. If I say refractive index of glass 1.5, this means light is entering from air to glass, and the formula is speed of light in air upon speed of light in glass. That is known as absolute. So got the student the formula of relative refractive index. Now student, I am coming to two more terms. See, rarer and denser medium. Now if you see the example I have written glass refractive index is 1.5. Remember, this is a student, I am talking about absolute refractive index. Means absolute means the one medium is air. Okay. And I have written refractive index of water is 1.33. Now you see whose value is higher, student. You can see it clearly, glass. So this glass will be called denser with respect to water. So if I compare two medium, glass and water, glass is denser than water, and glass is known as water is known as rarer medium. Okay student, so this denser and rare is decided by the term refractive index. If I compare air and glass, air, the value of refractive index is 1. For glass, the value of refractive index is 1.5. So now I think you can clearly judge which one is denser. Glass is denser than air, student. Okay, so this is the meaning of rarer and denser medium. How will you check it? You just check the value of refractive index. Now one more thing, remember student, refractive index, when I am saying simply refractive index, I am talking about absolute refractive index. Now if you see, remember the formula, it is the ratio of the velocity, so it has no unit. Remember student, refractive index has no unit. So how will you judge which one is denser and which one is rarer, student? By seeing the value of refractive index. And one more meaning of denser and rare medium is that if the light enters, the velocity of light will be much less in denser medium as compared to the rarer medium. For example, water and glass. Just now we have seen glass is more denser as compared to water. This means if light enters into glass from air, the velocity which light possesses in glass will be much less as compared to the velocity when light enters air to water. This is the meaning of this, student. So higher the refractive index, lesser will be the velocity of light in that medium. Now student, there is a very important law in physics known as Snell's law. In refraction, student, light travels from one medium to another, and out of this medium one will be rarer, other will be denser. So at the interface, what happens? Interface, you understand, student, where the two medium meets. Okay, say air, light is traveling air, and then suddenly the water comes. So the first phase which the water is in touch with the air, that is interface, it is known as. So whenever light travels from one medium to another, Snell's, one of the greatest scientists, greatest physicists, he has given a law related to that. And what is that law, student? See, here I have shown an example. Light is traveling from a medium of refractive index mu1 to a medium of refractive index mu2. I have drawn a normal. I is the angle of incidence, R is the angle of refraction. Now what Snell's has given is that the product of mu1 sine of the angle will be equal to product of mu2 and the sine of the angle of refraction. Means mu means refractive index, student, okay? Absolute refractive index. So this product mu and the sine of the angle theta. Theta means which angle is? It is the angle which the ray makes with the normal. There are two kinds of rays. One is incident ray, other is refracted ray. So this product will comes out to be always same for a particular medium, student. This formula was given by the very famous scientist known as Snell's. Now I will solve some numerical, student, to make the concept more clear. See, student, I have taken a problem here. First medium, second medium, can you see it? Mu I have written 1, mu written 3, 3 by 2. Angle of incidence 60 degree and angle theta I have to find out. So simply I will apply Snell's law, student. Mu1 sin theta 1, mu2 sin theta 2, the product will be same. Mu1 is given as 1, mu2 3 by 2. You solve it, you will get the value of theta. Now if you suppose you don't know how to find out theta, don't worry, student. In trigonometry, you will be solving it in detail in maths. And even I will explain you later on if you have a doubt regarding this. Now you just understand the physics behind it. Okay, student? So this is the angle you will get. Now, student, another very important hidden facts from the Snell's law, you see. Remember, student, every formula, every mathematical formula has a hidden secret behind it. And you have to find out that secret. It is the duty of the student to analyze and find out that secret. Don't just learn the formula and solve the question. Now I'm coming to that secret, student. Okay? Now see. Here I have drawn two figures. One, light is traveling from denser to rarer. In second case, light is traveling from rare to denser. Now, student, when I am saying denser to rarer, so denser I have represented it by mu1 and rarer I am represented here by mu2. So when I am saying denser, just now I have explained the meaning of denser, means its value of refractive index will be higher. So this means mu1 will be greater than mu2 in this case, student. Now you see the formula mu1 sin theta 1 is equal to mu2 sin theta 2. Product has to be same. Now if you check the formula, mu1 sin theta 1 and mu2 sin theta 2. The case which I am discussing, mu1 is higher, I have drawn the arrow upwards. Mu2 is less, I have drawn the arrow downwards. So in order to make the product same, student, see here the catch. In order to make the product same, the theta 1 must be less than theta 2, student. Then only the product will come out to be same. Since mu1 is higher, so theta 1 must be less. Since mu2 was less, theta 2 must be greater. So what is the meaning of, student, theta 2 greater? See the figure now. The light is bending away from the normal. So just remember, student, this product mu sin theta, this product has to be constant. So if mu is higher, theta will become less. If mu is less, theta will become higher. Just by simple this concept, you can write the whole law of the Snell's. Now you see the second case. Here light is made to travel from rare to denser. Now mu1 is rarer, student. Mu1 is rarer means the value of mu1 is less than mu2. Again you see the product mu1 sin theta 1. So if mu1 is less, theta 1 has to be higher than theta 2. So this means theta 2 is less. So what is the meaning of theta 2 less? It is moving towards the normal, bending towards the normal. Remember, student, angle is measured with respect to the normal to the surface. And normal, already you know it. You draw a line perpendicular to the surface at the interface. Okay, student? So in this case, theta 2 will be less than theta 1. So this in words I can say, when the light travels from denser to rarer, it bends away from the normal. When light travels from rare to denser, it bends towards the normal, student. Okay, student, this numerical is clear. You solve some other question also. Let's see some other numerical, student. See. Here I have shown one example. Light is entering from glass to water. Glass has a refractive index 1.5. Water has a refractive index 1.3. Now can you draw the path? Here already I have drawn the path. Suppose only the light of the first medium is given. Okay. You have to draw the second. How will you draw it, student? check, mu1 is 1.5, mu2 is 1.33. So mu is higher and mu2 is less. So mu2 less means theta has to be greater, and you see the light is bending away from the normal. See the student second figure. Here mu is 1.33, glass 1.5. So mu is less and mu1 is less, mu2 is greater. So mu2 is greater means theta has to be less, and you see the figure. Light is bending towards the normal. Can you see the figure, student? Light is bending towards, like this you can draw. Now see this figure, student. Light is falling normally on the surface. You apply Snell's law, you will get R to be 0, theta 2 to be 0. So light will follow the straight line path in this case, okay? So when the light falls normally, it will travel straight without any bending, student. Now see, student, here one question. See, I have shown one figure. Two medium, mu1, mu2. I have drawn mu1 arrow downward, means mu1 is less than mu2. This means light is traveling from rarer and denser. The question is, you have to say in which medium velocity of light is greater. Which medium velocity of light is greater? So how will you solve it, student? Just see the solution of it. Snell's law. Product mu1 sin theta 1, mu2 sin theta 2. Okay, student. Now in this question it is already given. Mu2 is greater than mu1. And what is mu, student? Velocity of light in vacuum upon velocity of light in medium. This means higher the mu, velocity will be less. This theory you have to apply. Velocity will be higher in mu1 in this case, because you see mu1 has a less value. So remember the relation, student, between mu and refractive index. Higher the mu, relation between mu and velocity. Higher the mu, lesser will be the velocity, student. Higher the mu, lesser will be the velocity, student. And what is the meaning of refractive index? It is a term which measures how much time the velocity of light will reduce when it enters any medium from one medium. If I say the refractive index of a medium is 3, suppose. If I say refractive index of a number is medium is 3, this means when light enters that medium, the velocity of light will become 1/3. You divide that 3. By which quantity will divide that 3? By velocity of light in vacuum. That is the meaning, student. Means velocity of light will become 1/3 of the velocity which was there in air. Okay, student, thank you for listening it so carefully and try to solve the question of refractive index. Again, I will continue with the more basic concept in the next class, student.